Yes, are you able to see the PPT?
Yes, sir.
Yeah, thank you. So before I take up this topic, just I would like to ask few things what I discussed so far. Okay. So Lavanya, can you say what are the key enabling technologies for this LTE?
So last
Lavanya.
class, sir.
Fine. Earlier to that also I thought because this
No,
is
sir.
my fifth
I
hour.
didn't.
Today is the fifth hour. So far you have not attended even single class.
No, sir. I was not well.
All, oh, all four classes you have not attended. Okay, fine. Then I have asked the wrong candidate. Okay. What about Dharma? Dharma. Yes, Dharma. Yeah, you speak na. Just saying yes. It won't help na. Unmute and talk na. So busy.
No, sir. Yeah, mic it was not working, sir.
ಕರೆಕ್ಟ್ ಆಗಿದೆ ಅಲ್ಲ ವರ್ಕ್ ಆಗ್ತಿದೆ ಅಲ್ವೇನಾ ಅನ್ಮ್ಯೂಟ್ ಮಾಡ ಹೇಳ ವಾಟ್ ಆರ್ ದ ಕೀ ಎನೇಬ್ಲಿಂಗ್ ಟೆಕ್ನಾಲಜೀಸ್ ಜಸ್ಟ್ ಮೆನ್ಷನ್ ನೇಮ್ಸ್ ಯಾಕೆ ಸುಮ್ಮನೆ ಆಗ್ಬಿಟ್ಟಲ್ಲ ಕೀ ಎನೇಬ್ಲಿಂಗ್ ಟೆಕ್ನಾಲಜೀಸ್ ಯು ವಾಂಟ್ ಟೈಮ್
Yes, sir. 2 minutes. I'll tell, sir.
2 minutes. Okay, in the meantime I think others should take up. Meghana. Yes, Meghana. See, only once I will call. I will not call 10 times. When I name it, you people should unmute and answer. Otherwise, it becomes what I wanted to say. I should not. Eh? Calling 10 times to get the response is not good also. Yes, Nandish Reddy.
Sir,
Yeah, what are the key enabling technologies of LTE? Key enabling technologies. Are you aware or not? Yes, quickly you should respond, man. If you know, you say no,
Sir,
otherwise I will ask. Yeah, Dharma, tell me.
sir, OFDM,
Yeah,
multi-antenna techniques,
okay,
IP-based flat network architecture,
okay,
channel-dependent multi-user resource scheduling,
okay,
and SCFDE and SCFDMA, sir.
okay, man. Very good. So these are the 5 key enabling technologies, right? Which are adopted or used in the LTE, I said, right? So first one is OFDM, that is orthogonal frequency division multiplexing. Okay, and I discussed why OFDM has been selected as a technology for this LTE. Okay, what are its advantages? Okay, how it is going to enhance the performance and meet the requirements of the LTE system. The second one is, I said, SCFDA, that is single carrier frequency domain equalization, and a single carrier frequency domain multiple access, that is SCFDMA, right? So I said, what is the disadvantage in OFDM? Then why do we prefer this SCFDE or SCFDMA for uplink? Okay. So with respect to peak to average ratio, I said, so that is the main drawback in OFDM. So that cannot be used for uplink. Okay, especially the uplink that is from user equipment to the base station. So user equipment is basically a handheld device. So it requirements is what less battery life, less cost, right? And size of the device also should be less. It will be small. So to meet those requirements, SCFD or SCFDMA is the right technology. And third one, which I'm going to discuss now, that is channel dependent multi-user resource scheduling. Okay. Okay. So let me see what it is. Okay, channel dependent multi-user resource scheduling. Of course, we may not be able to get full idea of what it is in just one slide. So as we go in subsequent lectures, we will be able to understand. But let me try to convey what it is in uh, a few lines. Okay. So before I say what is a channel dependent multi-user resource scheduling, let me say what type of technology is used in getting this type of this. All right. So this is one of the technology, right? I said channel dependent multi-user resource scheduling is one type of technology which is used in LTE, right, for meeting the performance requirements of LTE, right? So as we know, the orthogonal frequency division multiple access is the multiple access technique which is used in the downlink, that is from uh, base station, or we say E node B, to the user equipment. Okay, so this OFDMA allows for the allocation of the resources, okay, in both and time, in both, that is in time and as well as frequency. Okay, so the algorithms have been designed to allocate the resources in a flexible and dynamic manner to meet the throughput, delay, and some other requirements. Hope you're understanding what I'm saying. OFDMA, that is what I said, orthogonal frequency division multiple access, allows for the allocation in both time and frequency, and it is possible to design the algorithms to allocate the resources in a flexible and dynamic manner to meet the throughput and delay and as well as some other requirements, right? So because of the availability of this OFDMA, and it supports dynamic channel dependent scheduling to enhance the overall system capacity. So now let me define what is this channel dependent multi-user resource scheduling. So to understand that, first we need to understand what is this frequency selective multi-user scheduling. Okay, so when do we call it is a frequency selective multi-user scheduling? So let us assume that each user, okay, will be experiencing uncorrelated fading channels. Okay, hope you are all getting this visualization. Each user, let us visualize that in one base station, that is in one cellular coverage area, there will be one ENB, right? Under that, there are several user equipments will be there. That is, several mobile users will be there. So each user will be experiencing uncorrelated fading channels. Okay, you all know what is correlation and what is uncorrelated, right? So with that type of experience, it is possible to allocate the subcarriers among users in such a way that the overall capacity is increased. Okay. Hope you are getting what I am saying. In such an environment, it is possible to allocate the subcarriers among users, so that will improve the overall capacity. Okay, so here the transmission power in each user's best channel will be focused. Okay, so with that we say the overall capacity is increased or improved. Okay, so this frequency selective scheduling requires good channel tracking. Okay, so that is possible in only slow varying channels. Okay, so while defining the channels, I said there are different varieties of channels. We say slow varying, fast varying, and other things. Okay, so with this type of frequency selective scheduling, so that requires good channel tracking, so which is possible only in slow varying channels. Since OFDMA, it is possible to have this frequency selective scheduling. So this OFDMA can combine, okay, this frequency selective scheduling can be combined with the multi-user time domain scheduling. Okay, that will call for the scheduling users during the crest of their individual fading channels. Hope you are. I will show the diagram. I have a diagram where I can say that how does it combines with the multi-user time domain scheduling, that will call for the scheduling users during the crest of their individual fading channels. So crest means peak, right? I will show with that example, I think, but right now I will show. So this is what the channel dependent scheduling is that. So I have taken two users, so that is a user 1 and user 2. I said it will be possible to combine time domain multi-user scheduling, right? And it will be possible to allocate at the crest of the each channel, right? So that is user 1. So here the peak of user 1 is there. So during that time, for user 1, the resource will be allocated. Okay. In this time interval, user 2 is having a peak value. So for user 2, this channel will be allocated. Okay. Like that. Next is user 1, and user 2 signal strength is low. So user 1 signal strength is at peak value. So for user 1, the channel will be allocated. So, and in the next channel, see, user 2 signal strength is at peak and user 1 signal strength is low. Hence, for signal, the channel will be allocated to the user 2, and it keeps going, right? I hope you are able to understand what I am saying. So only at the crest of each user, okay, at that moment of time, the channel will be allocated. Yes, so the scheduling will determine which user to transmit at the given time and frequency. So channel dependent scheduling aims to transmit using time frequency resources for which the channel is good, right? In this duration, in this time or frequency, for user 1, the channel is good and is having highest peak signal, right? So user 1 will be using this channel. And for user 2, he is at a very low signal strength, so he will not be able to use that. Similarly, I hope for in the next one, user 2 is at peak and user 1 signal strength is low. That is why user 2 will be using it. Okay. Hope this point is clear. Yes, people should respond at the crest of each. I said, no, the crest means that one, right? Peak value. So for user 1, user 2, I hope this example will make you to get clear understanding about this channel dependent scheduling. I am asking you people only, is this clear? Arey, respond, yaar. I am not talking to the stones. After showing with the diagram and saying how the channels or resources will be allocated for two users, okay, how it is scheduled. I said it will be scheduled at the crest of each user data, right? So it is at high data rate, and for user 2, it will be low data rate. It is this channel, right? In the next one, user 2 will be having high data rate and user 1 will be having low data rate. I can't say more than this. Okay. So when I'm saying here, right, the scheduling will be done during the crest of their individual feeding channels. The crest is what I said with respect to this example. Okay. Hope we will be able to get that, but not responding. So yes, some can respond. Have you got my point, what I said? How resource will be allocated?
Sir, sir.
Yeah.
So when user one is not using the channel, then will the user two have the maximum crest? So like, will the frequency be allotted to him?
Yeah. Not using, I am not saying he is not using it. So here, with respect to this example, now, so it is, I am showing here with the dotted line, that is the scheduled user, right? So in the first one, user 1 will be scheduled. Okay. User 2 is not scheduled because for user 1 is channel fading. This one is at the peak. Okay. So you will be able to get the better data compared to the user 2. And in the next time or frequency, so user 2 will be getting, right? Because hope you are getting now this point. User 2 will be allocated and not the user 1 because he is at the low data rate, right? Means his channel fading is at low. Okay, next one, again user 1 is at peak. That is why user 1 will be allocated and user 2 is at low. So you will not be getting that time or frequency slot. Understood my point?
Yes, sir.
I don't think no one will be able to say like this by taking x-axis as what your time frequency. That is why I said here scheduling determines which user to transmit at the given time and frequency. That is what the meaning of scheduling is. Okay, it will determine which user to transmit at the given time and frequency. So channel dependent scheduling aims to transmit using this time frequency resources for which the channel is good. So in case of this, you are writing number 1, number 2 with a different colors, right? So number 1 is for user 1 and number 2 is for user 2. With two different colors, it is differentiated, right? So in the first time frequency, user 1 will be allocated. In the next, user 2 will be allocated. In the next, user 1 will be allocated. And I have shown with the diagram why user 1 is allocated in time frequency at slot 1, because user 1 is having better signal strength compared to the user 2. That is why user 1 will be scheduled that time or frequency. The here time frequency is a resource, right? So that will be allocated to user 1. And in the next, user 2 is allocated, not the user 1. Okay, next, again, user 1 will be allocated, not the user 2, because user 2 signal strength is low. So like that is the channel dependent scheduling works. Hope clear?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Okay. So at the crest of each user feeding channel, right? In OFDMA, what I said, frequency selective scheduling can be combined with the multi-user time domain scheduling, which calls for scheduling users during the crest of their individual feeding channels. So crest is that peak value only. Okay, fine. So then the capacity gains are obtained by adopting the modulation and coding. So I will discuss about this. What is this modulation coding? Okay, AMC is known. That is known as AMC. That is adaptive modulation and coding. In the subsequent lectures, during that time we'll be able to understand that. So by using this AMC, we will be able to improve the capacity gain. Okay, with what signal to noise ratio conditions for each user subcarrier. And this is for slow varying channels, I said. Then for high mobility users, this OFDMA can be used to achieve the frequency diversity. Okay, so frequency diversity is possible for high mobility users with the use of OFDMA. So how do we do that? How do we achieve that frequency diversity? That is possible by coding and interleaving across subcarriers in the frequency domain using a uniform random distribution of subcarriers over the entire spectrum. Even about this coding and interleaving concept also will come in the subsequent lectures. So we'll see that. What is that? Okay. So the frequency diversity can be achieved for the high mobility users with the use of OFDMA, I said. So how do we do that? Frequency diversity, that is done by coding and interleaving across subcarriers in the frequency domain using a uniform random distribution of subcarriers over the entire spectrum. So the signal can be made more robust against frequency selective fading, or I say burst errors. Okay, so we'll see what is this frequency selective fading and all. I think that also comes once these topics are over. So at the beginning only, we are just saying what is what about the technology or technology which are used in LTE. That is why I will not be able to take you or give you the clear picture of all these keywords, but you should be able to at least remember what is frequency selective fading. So when I am talking in the subsequent lectures, you should be able to correlate that here. Okay. Then the frequency diverse scheduling is best suited for control signaling and as well as the delay sensitive services. So frequency diversity can be achieved with the use of what? OFDMA, that is for high mobility users, right? So this frequency diverse scheduling is best suited for what I said, control signaling and as well as delay sensitive services. So can I say voice is a delay sensitive service? Yes,
Yes, sir.
Can I say voice is a delay sensitive service?
Yes, sir.
Yes, no, because see here I am getting I sometimes I talk with loudfish because why? When I ask some questions, if you don't respond immediately, I am feeling it is more delay, right? You are not responding, right? And even you don't love to hear the voice with a lot of breaks, right? If I keep talking some words, if you are able to hear with lot of gap, then you will not feel that. You have a continuity, right? So that is a voice is one of the delay sensitive service. So for that, this frequency diverse scheduling is uh, means this type of frequency diverse scheduling is suited for the type of service, that is delay sensitive service, and as well as control signaling. So this control signaling is basically used for establishing the uh, connection before the real voice or data to be transmitted over the channel. First the handshake signaling will happen, okay, between various elements in the network. So for that, this frequency diverse scheduling is used. Yeah, so already I talked about this slide. I said what it is, okay. So at least you will be able to grasp and say what is channel dependent multi-user resource scheduling. At least with respect to this diagram, if you write, it will be a great understanding what I can say. Of course, I might have told many other things. So the key takeaway is this. Okay, how does it allocates the resources, okay, to the different users depending on what? Okay. So the next technology is the what? Multi-antenna techniques. So this is the fourth technology what I am talking. So which is used in the LTE. So why these multi-antenna techniques have been suggested in LTE? Because it provides a solutions to improve the link robustness. Okay, I hope what is link you all know. That is, link means what? It is a connection between user equipment and the other elements in the network. So the first element is what? That is E node B. If I show the diagram of that network, you will understand. So a link is that, right? So with the use of multi-antenna techniques, it is possible to improve the link robustness. Then it is also possible to improve the system capacity and as well as the spectral efficiency. Okay. The moment we say multi-antenna techniques, it should come to your mind that, okay, this technology is used to provide a solution to improve these three things. What are those three things? One is to improve the link robustness. Second one is to improve the system capacity. And third one is to improve the spectral efficiency. Yes, is it fine?
Yes, sir.
Yes, I am asking, is it fine?
Yes, sir.
Yes, sir.
Yeah. So
So
you
can
all
you
will
give
be
us
able.
examples?
Yeah, I will come. I will come. I will come. Okay. I hope at least you will be able to say, okay, multi-antenna techniques means for what purpose it is used. Okay. If somebody asks, you should be in a position to tell, yes, these multi-antenna techniques are used in LTE. Okay. Because it can provide a solution to improve what? Link robustness, system capacity, and spectral efficiency. These three things, right? So let us see how it can improve these things, right? Link robustness, system capacity, and spectral efficiency. So broadly, I discuss four multi-antenna techniques. In that, the first one is the transmit diversity. Okay. So transmit diversity, right? So this transmit diversity is used to combat multipath fading. I hope you know what is multipath fading. Are you aware what is multipath fading? Yes, I
No,
am
sir.
asking you people. You are not aware what is multipath fading. Then what did you understand? When I told about OFDM, no, I gave example, right? With the diagram it is there. You people are saying no, multipath fading. What is this? Are you able to see this diagram?
Yes, sir.
Yes, sir.
Have I not thought this? See here there is
Yes,
a base station, no? Right? So it will be, since the channel is wireless, right? So if the receiver is here, means if the user equipment is at this point, so this user equipment will be receiving the signal through different directions. Okay, one is maybe the line of sight, another one maybe is this path, another one maybe is this path, right? Yes or no? So this is known as the multipath fading, because what happens, the signal take its time to travel from base station to the user equipment uh, through different paths, right? At the receiver, what I said, it will be arriving at different intervals of time, right? That is known as the delay spread. So due to that only, we are facing this intersymbol interference. So I very much told this. I started this and why this OFDM is used. How does it? How OFDM can eliminate this intersymbol interference? Then people are saying you are not aware what is multipath fading. Huh? Then what is written here? See, multipath, then high delay spread, right? With this symbol duration, so the intersymbol interference can happen up to 100 symbols, right? Then I said, how do we overcome that with respect to this OFDM principle, right? Then with respect to the same example, I said how we can say there will be no intersymbol interference. Okay, fine. See, people should be attentive and should be able to grasp the concept because it is a system. So many things will be there to understand. So I will not be able to again, because once I keep moving, so when I ask something, you should be able to say. Since I'm in the same module and same this one, I can go back and show. Otherwise, it is difficult. Okay. So I said, yeah, this transmit diversity is used to what? Combat multipath fading in wireless channel, right? Okay. So of course, how does it eliminate the multipath fading, right? So the idea is here, it will be sending the copies of the same signal. Okay, it will be sending the copies of the same signal which are coded differently over the multiple transmit antennas. Able to visualize this? The sentence meaning? How the transmit diversity able to combat multipath fading in wireless channel. I'm saying about the idea, means what is this transmit diversity is. I said it will be sending the copies of the same signal. Okay, copies of the same signal which are coded differently over multiple transmit antennas. Since I'm using multi-antenna techniques, right, I can have more than one antenna at the transmitter side. Similarly, I can have more than one antenna at the receiver side, right? So I will be taking the copy of the same signal, okay, which will be coded differently. Okay, let us assume that I will go back to this diagram. Yeah, this one you assume. Okay, so I have here 4 streams of data, right? It is same data only. Let us assume that for this understanding, whatever there in blue, whatever there in red and other 2 colors, same data. Let us say it is hello, how are you? Okay, hello, how are you only I have copied 4 times. Okay, and that hello, how are you will be coded differently. I hope you know what you mean by coding, na? Source coding techniques you're using, right? Source coding. Okay, the same data will be coded differently. Then I will be transmitting that through multiple antennas. So by doing so, I will be able to eliminate the multipath fading effect. So that is what the transmit diversity is. Got my point? Yes. So transmit diversity will be able to combat multipath fading in wireless channel. How it will do that? By sending the copies of the same signal and coding it differently over the multiple transmit antennas, it is possible to overcome that problem. So this transmit diversity is basically based on space frequency block coding. So it is. I hope you might have studied a different channel coding techniques. I don't know whether you are aware of this space time block coding, then space frequency block coding. So this is the technique which is used to send that copies of the signal, same signal, by coding it differently over multiple antennas. That much I think we can grasp at this point of time. Okay, this space frequency block coding is a technique, right? Means this is a transmit diversity technique. So what it will do, it will take the copies of the same signal, it will be coding it differently, and it is possible to transmit over the multiple antennas. Especially this transmit diversity is intended for downlink channels, okay, where the channel dependent scheduling is not of that use, okay. And even we can use this transmit diversity at a place where user transmissions like low data rate voice over internet protocol. Okay, even in such cases also this transmit diversity can be used. So this transmit diversity will increase the system capacity and as well as the cell range. Okay. So you see, there is a relation between the number of antennas used at the transmitter side and the system capacity. Okay, if I use more number of antennas, then the system capacity will also increase. So I'm not going with that equation. So just I'm saying theoretically, by the use of this transmit diversity, it is possible to increase the system capacity and as well as the cell range. Okay, just to give an idea. Even other than this transmit diversity, I have shown here some other multi-antenna techniques also. Just you can have a look. So the first one is this transmit diversity for improved quality. So hope you understand. So this is your base station and this is your mobile phone. This is known as user equipment. Say the same signal will be sent, okay, over more than one antenna by coding it differently. So I said this is a downlink, right? That is from your E node B to the user equipment. Okay. So similar to that, there are some other techniques. So you can have a look of that. In the subsequent slides, I will discussing about those techniques also. Hope got this point. The transmit diversity. Yes, any one of you can say what is transmit diversity? Hello. What is transmit diversity? Madhura, can you say?
Yes, sir.
Yeah.
So transmit diversity is used to send copies of the same signal,
Yeah.
and it is based on space frequency block coding, sir.
That is fine, but you are missing next. It is used to
It
send
is
the
used for
copies of the same
downlink, sir.
signal. No, that is next point. See, sending copies of the same signal by coding it differently.
Over
That is
multiple
important.
transmit antennas.
Over multiple transmit antennas. So that should be very clear. Otherwise, what it happen? It will be very means it is off, no?
Yes, sir.
Right?
Yes,
Yeah.
sir.
The idea of transmit diversity is what? Sending the copies of the same signal by
Coded
coding it
differently.
differently over multiple transmit antennas.
Yes, sir.
So with that means for doing that, what is the type of method is used? That is space frequency
Block
block
coding.
coding is used. Okay. Then you have to tell, okay, it is implemented for downlink right?
Channels.
And yeah, downlink channels, and even it can be used for some other low data rate voice over IP system also. Okay, so with the use of transmit diversity, we will be able to improve the system capacity and as well as the cell range. So cell range means the coverage area. Okay, if one particular cell is able to cover an area of 1 kilometer, with the use of transmit diversity, it is possible to extend its coverage range, maybe for 1.5 kilometer or 1.2 kilometer, like that. Is that fine?
Yes, sir.
Yeah, and even I am showing here this with picture also. Okay, so this is our base station. So the same copy of the signal will be sent through two different antennas. So that's the downlink. So similarly, you just have a look, or we'll come back to this slide, because then and there only we'll be able to understand. Otherwise, now in one stretch, if you keep seeing everything, nothing will be able to grasp what I am saying. Okay. So next one is, even in the next case also, I have shown some diagrams, which is which tells about these techniques. Okay. Okay. Yeah. First one is, as I said, transmit diversity, right? So second one is beam forming. Able to see this beam forming, the diagram? What do you understand from this? So beam forming is used for improved coverage. Okay. Though we are using multiple antennas, okay, the coverage will be focused towards the receiver, intended receiver. The coverage will be focused towards the intended receiver by uh, having a, or by increasing the gain of one particular antenna, okay, towards the intended receiver, and that is known as the beam forming. Even in the previous case also, you can see that beam forming. Yes, of course, here is there this diagram. Beam forming to increase the received power and as well as signal to noise ratio. Okay, just keep these figures in your mind, so that when I am going to the next slide, if I am saying in words, you'll be able to understand that. Got this point? Beam forming, at least, so like this is a pencil beam, what we can say, right? So from one, it is intended towards the intended receiver. Okay, so now I will go with theoretical this one, right? So what I say is here, beam forming means, here the idea is we use multiple antennas in the LTE, right? So that may be used to transmit the same signal, okay, appropriately weighted for each antenna element. So here each antenna weighted means can set the gain. Okay, by increasing the gain, we will be able to focus it, that coverage beam, right? So we use multiple antennas to transmit the same signal by with what appropriate weight for each antenna element. So with that means, with the proper weight, we will be able to focus the transmitted beam in the direction of the receiver. Okay, means only for intended receiver it will increase the signal strength, not for others. Okay, so the purpose of using this weighing means the different antenna gains, right, is to focus the transmitted beam in the direction of the receiver, intended receiver, and away from the interference. So with that, we will be able to improve the received signal to interference ratio. Okay, so this is what the second multi-antenna technique is, that is beam forming. Okay, so this beam forming can provide significant improvements in coverage range, capacity, reliability, and battery life. Okay, so these are some of the advantages of beam forming. Okay, and this beam forming can also be used to provide angular information for user tracking. Okay, so this is another application of this beam forming, and this LTE supports this beam forming in the downlink. Okay, so beam forming cannot be done in the uplink. Okay, it is used in the downlink. Downlink means that is from base station to user equipment. Okay, hope Clear this idea? Beamforming. Yes, what is done in beamforming? Any one of you can say? Yes, quickly. I don't want to mention the names, or I will call. Beamforming. Yes, Vandana, can you say what is beamforming?
So, improvements in coverage, range, capacity, and battery life,
Yeah, that
and
is
it is
fine. That
used in
is the,
sounding.
yeah, that is all fine. Advantages you are telling, where it is used and all. What first you should say what is beamforming, na? So you are not catch that point. Beamforming. So we are using multiple antennas, okay, to transmit the same signal by using appropriate weighted gain to each antenna. So with that, we will be able to focus the power to the intended receiver and to be away from the interference. Okay. So by using, so this is what the beamforming is. Though if I have multiple users in this, the radiation pattern of this antenna will be focused towards only the intended receiver, not to others. Okay. So that is possible with weighted gain at the transmitter side for the antennas. Okay. So how I can focus radiation pattern to only particular receiver by having more gain. Okay. For other antennas, the gain will be reduced so that it will not be beamed or focused towards other users. Okay. So that is what I said here. Multiple antennas in the LTE may be used to transmit the same signal, appropriately weighted for each antenna element. Okay. So by having proper weighting of the antenna, then I can focus the transmitted beam in the direction of the receiver and away from interference. Away from interference means not for the unintended users. So with that, I will be able to improve the received signal to interference ratio. Okay. So then what you said is these are all the advantages of beamforming. So it can improve coverage range, capacity, reliability, and battery life. Right. And I said it can also be used to provide angular information for user tracking. Okay. Okay. So I wanted to throw one more just example or a picture. How does the beamforming use? Right. Why use beamforming? Just have a look here. If I use single antenna, so it will be radiating in omni directions, right? This is what the coverage is. Then if I use few antennas, that is more than one antenna, I will be able to concentrate like this. Then if I use many antennas, that is array of antennas, if I provide proper weightage to each of the antennas, then I can focus the radiation pattern of that to the intended receiver. Okay. Just to throw some more light on that, so I have taken this slide. Hope at least we will be able to say what is beamforming. So this is used to, beamforming is needed to compensate very high losses at higher frequencies. It's all fine. Then okay. So use a wider number of transmit receive antennas, that is radiating elements. Then width of the beam is narrower as the number of antennas increases. Okay. And then I said all the power will be confirmed, okay, in certain direction. That is for the intended user. So this is the second one. And the third technique under multi-antenna is the spatial multiplexing. So spatial multiplexing is nothing but MIMO only. Okay, that is multiple input, multiple output. So what happens here is, see, multiple independent streams, right, can be transmitted in parallel over multiple antennas and can be separated at the receiver using multiple receive chains through appropriate signal processing. So just now I have shown the diagram for explaining the transmit diversity. Now the same diagram I can take it for explaining the spatial multiplexing also. This one. Okay. Now what you need to assume is the data is different in each stream. Okay. So I am able to transmit parallelly these four streams of data through four different antennas. Okay, and this is what the MIMO channel is. So at the receiver side, again, I will be using same set of antennas, right? Then I will be able to get back the proper signal to the intended receivers. Okay, so this is what the spatial multiplexing is. Yeah. So here also one diagram which shows about the spatial multiplexing, right? So this is one receiver, this is another receiver. So how it is, the beaming will be steered, right? Yeah. Fine. So I said multiple independent streams, right, can be transmitted in parallel over multiple antennas and can be separated at the receiver using multiple receiver chains through appropriate signal processing. So this spatial multiplexing can provide the data rate and as well as the capacity gain, which is proportional to the number of antennas used. Said no, the number of antennas and the capacity is directly proportional. Okay, as the number of antennas increases, the capacity of the system will also increase linearly. They are related linearly. Okay, so as of now, this LTE supports the spatial multiplexing with up to 4 transmit antennas and 4 receive antennas. Okay, so the maximum number of antennas can be supported by in LTE with the spatial multiplexing technique is what? 4 antennas, 4 transmit and 4 receive antennas. Fine. So this is the third multi-antenna technique, that is spatial multiplexing. And the next one is multi-user MIMO. So before I come back to this, before I say theoretically with this one, let me show the diagram. What do you mean by multi-user MIMO? Okay. Is it possible to identify where the multi-user MIMO is there among these 5 diagrams? Yes, any one of you can point out where the multi-user MIMO diagram is shown.
Third figure, sir. First to
Yeah,
third
third figure, right? So third figure is the multi-user MIMO concept. For illustrating the concept of multi-user MIMO, this is the diagram. So at least looking at this diagram, you will be able to understand that this multi-user MIMO is for uplink, okay, not for downlink. Hope you are understanding looking at the diagram, because it is from user equipment, that is from mobile to the base station, right? So it is for uplink only, not for downlink. Okay, because why the spatial multiplexing is not adopted in uplink, because it requires more number of antennas, right? So as the number of antennas increases, even the processing related circuitry, power consumption, cost, everything goes high. So that cannot be offered for the handheld device. So that is why spatial multiplexing technique cannot be adopted for uplink. It is only for downlink. But this multi-user MIMO is adopted for uplink. Hope you are able to grasp this diagram. Just understand this diagram, what it is. Means what you are able to infer from this diagram. So this is user 1, you understand. This is another user, right? So each user will be able to communicate to the base station simultaneously, okay, at the same frequency and at the same time. So at the receiver side, and this means at the base station, it is possible to differentiate the signals from different users, okay, from different users by using the reference signal, okay, that is known as the channel state information, so which is provided from each user. I will say that very clearly with the sentence. Yeah, so what I said, this multi-user MIMO allows multiple users in the uplink. Okay, it allows multiple users in the uplink, each with the single antenna, to transmit using the same frequency and time resource. Okay, each user will be having a single antenna only, okay, they will be able to transmit using same frequency and time resource. That is possible. So how the signals will be separated in the base station? Okay, so that is I'm saying next. The signals from the different multi-user MIMO users are separated at the base station receiver using what? Accurate channel state information. That is, we say CSI. Okay, channel state information of each user, which is obtained through uplink reference signals. Okay, this channel state information of each user will be obtained using the uplink reference signals. Okay, and those uplink reference signals are orthogonal to each other, means they are orthogonal between users. So there will be no overlap or interference among these uplink reference signals, which are used as a channel state information to convey to the base station. Hope got this point? Yes, I am asking. Hope you got this point. How this multi-user MIMO works. So it allows multiple users in the uplink, right? Each with a single antenna to transmit using the same frequency and time resource. Okay. So how does it supported? I'm saying this, right? The signals from the different multi-user MIMO users are separated at the base station receiver using accurate channel state information of each user, which is obtained through uplink reference signals. Okay, and those uplink reference signals are orthogonal between the users. So this is another multi-antenna technique which is used in LTE for uplink. Yes, hope you got this point. Multi-user MIMO. So yeah, so before I wind up, I want you people to just summarize. I think those who have interacted with me so far is fine, but others should now respond. Okay, I asked from my side some questions to some students. They could respond to certain extent. Yes, it is good. At least now, before I call from my side, if they are individually able to come voluntarily to come forward and summarize what they have understood in today's lecture, it is highly appreciable.
So,
Yes.
so what is uplink reference signal?
Yeah, uplink reference signal. See, reference signal means from user equipment to the base station, it is like a control signal only. Okay. I hope I have shown as a pilot carrier, na? Pilot carrier. While explaining about OFDM, I have shown pilot carriers. Like that, here for each user, there will be one signal. Okay, they will be sending that reference signal to the base station. So based on that uplink reference signal, the base station will be able to differentiate. Okay, it is from so and so user. Okay, this data is from user 1 and this data is from user 2 and this data is from user 3, like that. Hope you got my point.
Yes, sir. Then what is the difference between channel state information and uplink or reference signal?
No, the channel state information as what? Reference signal only. Okay. Means what? The channel state information, that is the name, right? Means it will intimate about the user information, na? About that channel, it is intimating to the base station. Okay, this data is from user 1, this data is from user 2, this data is from user 3. To know the base station, which data is from which user, that will be conveyed through that reference signal. That is what we call that as a channel state information, CSI. Yeah, fine. Others, any questions they can? Yeah, quickly, I think next class is there. In 1 minute, you people should be able to summarize at least what I thought today. If not in detail, yes, before I wind up. Yes, Siri and Rao, can you just summarize? Siri,
Yes, sir.
yeah.
So we learned about spatial multiplexing and beamforming and why beamforming is used and the multi-user MIMO.
Yeah. Yes, that's all. Siri? Okay. Yes, what about Pranav? Yes, Pranav.
Yes, sir.
Yes, I'm not able to hear Siri voice. Can you just do the summary? Pranav?
Yes, sir. I'm here, sir.
Summary ಹೇಳ ನನಗೆ ಇದೆಯಾ ನೀನು ಗೊತ್ತು What is the takeaway of today's class, man?
So, like, we learned about multi-antenna transmissions and MIMO, sir.
Okay. That's all. Only one technique.
So, no, sir. And about beamforming also. Like,
Yeah, that comes under
we are
multi-antenna
doing that
techniques
in
only, no?
Sir?
ಏನು ನೋಟ್ ಮಾಡ್ಕೊಳಲ್ಲ ಅನ್ಸುತ್ತೆ ನೀವು ಹೇಳ್ಬೇಕಾರೆ PPT ಎಲ್ಲಿ ಹೇಳ್ಬೇಕಾರೆ ಸ್ಟ್ರೆಸ್ ಮಾಡಿ See, I discussed about two major technologies. One is channel dependent multi-user resource scheduling. Okay, what it is, how it is done. Then the second one is multi-antenna techniques. Okay, under multi-antenna techniques, I discussed four. One is transmit diversity, second one is beamforming, third one is spatial multiplexing, and fourth one is multi-user MIMO. Okay, so at least to do summary, you can do that only if you note down when I was teaching. Okay, if you don't note down any points, then it becomes very difficult. Okay, so with this, let me stop. For again, I will come back for fifth hour. So that is at 1:45. So as of now, you all can write your USN in the chat box. That will be your attendance. Okay. Yes, quickly you should write your USN in the chat box. Then let me stop.